Today in this video, we're going to be doing some Civil FE exam review, and we're going to be focusing specifically on statics. So I do have some practice problems for you all, and I hope that this content will be valuable to you. So let me minimize myself, and let's get straight into the content. All right, so I'm at the bottom of my FE manual. And like I said, we're going to be talking about statics. And in the last video, we went through frames and trusses, but we focused specifically on method of joints. And today we're going to be focusing on method of sections. And this video is for anyone who is wanting to kind of get a little bit of a refresher on how to break down these different problems that are going to be on your exam. So I do take my time with these problems just so that it is clear and so that you understand what's going on. All right, so let me slide this over and I want you guys to take a look at this practice problem. All right, so it says, use method of sections to determine the internal force at EF. Okay, so they want to know the internal force here at EF. And as you can see, there's this dashed little green line coming across. And that is going to be a cut that we do to determine that force in between there. So a few things that I'm thinking here just off tops. Looks like there's some unknowns for my pen and my roller, so there's just something to keep in mind. And I know that I'm gonna have to cut this and break this up into parts and see how I can maybe take a moment or something to get that force there. But before that, before I even take a look at the problem, I normally ask myself, can I use the FE manual for this problem? And I guess you can say we can search something up really quickly. So I just normally go and control find, and I do method of maybe sections, and there's 12 things that come up. And since we're in the static section, and since we're in trusses, method of sections, we know that we're exactly where we need to be. And I thought it was 12, but it was only 2 things that came up. So I'm assuming that other thing was, letting you know what page you can find this at. So I don't know why this hand thingy is in the way, but yeah. So it says the method consists of drawing a free body diagram of a portion of the truss in such a way that the unknown truss member force is exposed as an external force. So that just basically means we're drawing a free body diagram of the portion of the truss, and so that we can get the unknown member force exposed as an external force. Okay, so easy enough. That's all they're going to give you for this. So that means you need to know how to draw free body diagrams, right? So let's go ahead and close that down. All right, so first things first is, before we can find internal forces, we're not going to be able to do anything with this until we find our the forces at our pen and our roller. So let's start there. And you may not have noticed, but I was scrambling to find my pen, so I'm good to go now. All right, so first start out, and we're just gonna say, looks like we got 2 unknowns and some forces that we do know. So I'm thinking that we should just take a moment to start. So that's going to be the fastest way to get this problem done. So I'm going to take a moment about D, which is going to give us and remember when you take in moments, it's just force times distance, right? So, little background. These are equilateral or equivalent triangles, basically. So this is 6 meters here, 6 meters here, 6 meters, and in between is 3. So just something to keep in mind for our force and our distance. So I'm going to say minus 10 kilonewtons. Okay, and I really don't want to write all that out. So it's minus 10 kilonewtons, so you know what I'm doing, times 3 meters. Okay, and then minus 20 kilonewtons times, okay, we got 6, and then another 3 because it's in the middle, and that's our perpendicular distance. So that's going to be 9. And then minus 10 times 6, 6, and then 3. So that's 15. And then we got this upwards gy, right? And then times with 6 times 3, 18, right? Notice you also could have solved this from symmetry, but you really got to be understanding of all this. So I just am keeping it simple and not trying to just say you're gonna be able to look at this and say, oh, it's symmetrical, but that'll save you a lot of time, right? I get negative 30. And I'm a bit slow, so please feel free to skip past me if you find yourself getting answers before me. And also, if you're finding some value out of this video, please hit the like and subscribe button. All right, so I'm getting gy to equal 20, and that's kilonewtons. And that's just saying in the upwards direction, all right? Just saying we drew it right. All right, so now we can do the sum of the forces, and the y is equal to, well, we got negative 10 kilonewtons down, right? We got negative 20 down. We got negative 10 down, and then we got plus 20. And then we got plus dy. So that means dy should equal 20 as well. All right, and the upwards force. So we got 20 on this side, 20 on this side, and that's 40 on the bottom, 40 on the top. So we know this makes sense. Okay. Oh, and I forgot about one other thing. So we got the sum of the forces and the x is equal to, okay, just dx, right? I don't see any other looks terrible. I don't see any other forces, so G equals 0. Okay, so now what we want to do is, being that we have that information, we want to go ahead and break our truss up. Okay, so remember those numbers, 20, 20, and 0. So I'm going to erase. We did part of it. And I've been getting some comments about making my stuff a little bit more easy to follow and not as time consuming. So I took the constructive criticism, and hopefully this is already clear so we can move right along. So all right, so I broke this up, just cut it where it's literally shown in green, and now we can see our horizontal forces, and we can also see our EB, EF, AB. There's a few missing forces that I have not included, and I'm also going to show where our point B is. So that's very important. And we also have a force of 20 kilonewtons, and we just saw it for that. So hopefully that makes sense. And this force is 0. Okay, so we got our pin. All right. Next, what we want to do, and keep in mind our distances, 4 and 6. So now what we want to do is we want to find the, oh, and I forgot my horizontal forces. We got one coming down, and that one's 10 kilonewtons, and we got one coming down here, and that one's 20. Okay, so what we're gonna do is we're gonna, when you break this up, you just want to look and see where maybe you can take a moment, and it will allow you to get some clarity on your unknowns. So by gauging this, if I take a moment at D, it's not even EF is going to be, there's no perpendicular distance from D. So, I mean, that's going to be EF times 0, which cancels out that whole, I guess, function. So that wouldn't make sense for me to take a moment there. We could take one at A, and we could also take one at B. And if you want to test all those, it's cool. Should get the same answer. I'm just going to take one at B. So we're going to do the sum of the moment at B is equal to, just go from left to right, and that's going to be a negative 20, right? And then times, well, what's my distance from dy to point B? Well, it's 6 plus 3. That gives me times 9. Okay. And we also have that 10 newtons coming down. All right. So plus 10. Coming down, and that distance is 6, right? Okay. There's no force in the AB. Okay, we do have this EB. So this is where it kind of gets complicated. And what I'll do is I'll maybe switch colors so that it isn't so complicated. Just do green. All right, so what's important here, oh God. When I tried this before, I kid you not, it worked. I just knew my colors were gonna change. So good. Anyways, saying all this because there is literally a force in the X, I mean, a force in the Y for EB, and there is a force in the X for EB. So force in the Y and in the X. As you can see, I try to draw it with small dashed lines, which probably is not that helpful, but hopefully you get the point. So remember, when you're taking moment, it's just force times distance. So we want to break this EB force so that it's not so complicated into a force that is specifically happening in the Y and that is specifically happening in the X. So we're going to break it up. So we'll start with the Y, all right? So it's coming straight up. And so what that force looks like is this force or this moment is actually a negative moment. Because if it's coming up and around point B, that is clockwise, which in my eyes is negative. Okay. So hopefully this will make sense once I write it out. But it's a negative moment times EB. And this EB is, that's not the force, right? And the Y, it's definitely not the force in the Y. What's the force in the Y? Well, the force in the Y would be EB and then opposite over hypotenuse, right? So it'd be sine or opposite, which is 4 over 5. Where did I get 5 from? Okay, I got 5 because it is the hypotenuse of this triangle. It's a 3, 4, 5 triangle. And the way that you get that is basically you take 3 squared plus 4 squared, and that should give you 25, right? And then you take the square root of that, which gives you 5. So if you want me to write that out, it's just 3 squared, right? This is just 3, and then plus 4 squared, and take the square root of that, and that's going to give you your hypotenuse. And what that's hypotenuse. And what that this is your hypotenuse, and this is your 3, and this is your 4. Yep. So that's how you get 5. Okay. A little bit of basic kind of, I'm sure everyone knew that, but I don't like to skip steps and then you're confused for the rest of the problem. So I know how that feels. Okay. So I got EB times 4 over 5. Okay. That is only my force. So I still need my distance. Just gonna scoot this over some. Okay, what's my distance? What is my distance coming? Oh, that is perpendicular to get to point B. Well, it is just gonna be, should just be 3, all right, coming from point E. Over, yep, 3. So multiplied by 3. Okay, we're not done. We did our y, all right? So now what is our x for EB? So if we have a force pushing to the right, up and around, all right? That's a positive. It's a positive force. It's a positive EB force. Okay, but instead now it will be cosine, right? Adjacent. So that is going to be 3 over 5. And then we're going to multiply it by the distance. So if we have a horizontal force, what is the perpendicular distance to B? All right, it's just going to be 4. All right, and as you can see, those EBs are going to cancel, but we're going to continue with the rest of our forces. So we should have, so we've taken care of our dy, which was 20 kilonewtons. We've taken care of our 10, our moment for the 10 kilonewtons. We've taken care of our moment for EB. And now we just have to take care of our moment for EF, because at the moment at B is just 0. So EF is just a horizontal force, all right, and it's coming up and around, so that's a positive. EF, and we're going to multiply that by the perpendicular distance, which is just 4. Okay, so these ultimately cancel, and you're left with negative 20 times 9 and plus 60. Right. And then you're going to divide that by 4. And so you get EF is equal to 30 kilonewtons. Hopefully this made sense to you. The important thing is these EBs, sometimes on solutions, they won't even show you why these forces cancel out, and it's very important that you understand the concept. So I hope that this was helpful for you. Be sure to check down in the description box below. I do have a ton of resources for you, things that'll help you pass, programs that are out there, courses. If you want to work with me one-on-one, whatever it may be, even more practice problems, solutions, and things like that. Make sure you subscribe to the channel if you're finding these videos helpful, because I am dropping as much content as I possibly can on this channel. So if you have any questions, let me know. Be sure to leave it in the comment section. And we are going to be going through what is next for us. 478. I will be covering centroid of area, so that should be interesting stuff. So I will see you all in the next video. Peace.